You're doing number 3?
Yeah.
Okay.
All right, number 3. The position of a particle
So why don't
moving.
you slide it up a little bit?
Right.
There you go.
Perfect. The position of a particle moving along a line is given by S of t equals 2t cubed minus 24t squared plus 90t plus 7 for t greater than or equal to 0. For what values of t is the speed of the particle increasing? So this is essentially the position function. So I took to the second derivative to get the acceleration function, and then t has to be greater than 4 to make this true for t equals greater than or equal to 0. So that would be where it's increasing because it has to be greater than 0.
So speed is increasing.
When acceleration is positive.
No, it's when both the velocity and the acceleration are the same signs.
Oh. Okay. I did that one wrong then.
Well, no, it's not. So what you want to do is take a look at, I think you can factor the first derivative. So why don't you take the first derivative, make it equal to 0, and divide everything by 6. Do you have a writing instrument up there?
You have your pen. Everything by 6.
Yeah, the first derivative.
Let's make that equal to 0.
And make it equal to 0 and divide everything by 6. I think you
Okay.
get t squared minus 8 plus 15.
Okay. Minus 8 t plus 15. Right?
Yeah, and so if you can factor that, correct?
Yeah.
Okay,
5 and 3.
5 and 3, yeah.
T plus minus 3 and minus.
Minus 5.
Yeah.
So then you want to take a look at your intervals from, I suppose, what does it say?
3 and
Does it say
5.
that, oh, t is greater than or equal to 0, so from 0 to 3, from 3 to 5, and from 5 to infinity, correct? I want you to take a look at those intervals.
Take it.
Because the roots are where it like switches is from, is it 3 and 5?
Yeah.
So
Yeah.
you'll have 3 intervals where velocity changes.
You want me to take a? What do you mean take a look at those intervals? Like plug them in my. I don't know. Type that.
So what you're going to do is you're going to do a first derivative test. You're going to have 3 intervals. So make an interval 0 to 3,
Yeah.
make an interval 3 to 5, and make an interval from 5 to infinity. There you go. Perfect. And we can pick 1, right, for the first interval. And if
And
we
plug it in the
pick,
first derivative.
if we pick 1, it's positive, correct?
Yeah.
Okay,
And
so
four.
put a
Okay.
increasing that the function's increasing, right? Velocity's increasing, yes ma'am.
4
Start plugging T's, which equation for this one?
Okay, so this one, we're putting them back into the first derivative or the velocity function. And since it's positive, right, it means our function's increasing, right? Our position function's increasing. But it's positive. That's what, I just need to know that it's positive. And so for the next one, you're gonna put in 4. And if you put
Yeah.
4 in there, you have 16 minus 32 plus 15, that's negative, correct?
Yeah.
So you're gonna have a minus there. And then from 5, I put 6 in there, I'll have
Yeah.
36 minus 48 plus 15, that must be positive.
Yeah.
Okay? So put a plus there. So now we're gonna take a look at you came up with 4, correct? For your second derivative,
Yeah, where it's greater than
right?
0, yeah.
So between 0 and 4, so we're gonna have a new line, okay? From 0 to 4, we'll pick 3, right, into the second derivative. And I'll have,
So-
if I pick 3, it's negative from 0 to 4. Does that look correct? Because it's 36 minus 48, or,
Yeah.
right, if I put 3 in there? So between 0 and 4, it's negative.
Okay.
All right, so it's the same sign from 3 to 4, right?
Yeah.
So the first derivative is negative from 3 to 4, and the second derivative is negative from 3 to 4.
So from 3 to 4 it's increasing. Is it increasing after that too? Or-
Well, then let's take a look. Right, agree.
Yeah,
So if we
4 to
look
infinity.
beyond 4, the acceleration is
5.
positive, correct?
Yeah, which is good from 5 on.
Yeah, so we have 2 intervals from 3 to 4 and from 5 to infinity. Very good, very good. Excellent.
5 to infinity. Should be good.
Okay,
Yeah.
and I'll show a graphic on that in a bit, what I mean by that.
Yeah.
Okay. Now, we're doing number 4, correct? And I gotta go to the machine. And number 4 who was number 5 in here? Has that person already gone?
Yes.
Okay. Who's number 6? Okay, number 4. Is it okay if I do number 5? Because I enjoy doing number 5. If it doesn't bother anybody. So thank you for giving me the opportunity.
So we have
Okay.
number
Yeah,
4.
so-
I love not understanding things.
No, but it'll be better this time because I'm not writing anymore
Nah,
and I
we're
can
good.
talk about the score.
So-
I was hungry when I was talking.
We
Okay.
got a particle moves along the x-axis so that at any time t is greater than or equal to 0, its velocity is given by v of t is equal to 3 plus 4.1 cosine of 0.9 t. What is the acceleration of the particle at time t equals 4? So first we just take the velocity, the derivative of the velocity. So you get negative 4.1 sine of 0.9 t multiplied by 0.9, and then you just plug in 4. Which is
So that's A of t, that equation,
Yeah.
correct? So you'd write A of t equals that,
yes,
and then you'd say A of 4 is whatever value.
yes. A of 4 is equal to 1.952.
2. They don't
That's
give you
it.
any units, do they?
Nope.
Okay, fine and dandy. All right,
That's
super.
it.
I'm gonna do number 5. And I see you have number 5 correct. So number 5. I'll do right here. I don't have a green sheet. And number 5 says this: a particle moves along the x-axis so that at any time t greater than 0, its acceleration is given by this. So A of t is equal to the ln of 1 plus 2t. If the velocity, if v of 1 equals 2, what is the velocity at time 2? Right? And so I can integrate from 1 to 2 a of t dt, and I know that's going to be the antiderivative, which is v of 2 minus v of 1, correct? And so v of 2 is what I'm figuring out. V of 1 is 2. And so one way I could do it is I could, using my calculator, figure out what this function, what this area is, and add 2 to it. Right? And that would give me v of 2. And my guess is that's what you did. Okay? And that would be a correct way to do it. The question is, can you figure it out a different way? And in other words, can we figure out what v of t is? And so what I did is I did that, and this is how I did that. I said, let u be 1 plus 2 to the t. And so what I'm going to do is find out the antiderivative of this. And then I figured out du dt. And du dt is the ln of 2 times 2 to the t. And that means du divided by the ln of 2 times 2 to the t is equal to dt. But if u equals 1 plus 2 to the t power, u minus 1 equals 2 to the t. So I rewrote it one more time as the ln of 2 times u minus 1 is equal to dt. So I wrote this. I got the ln of 2, there's my constant. I got the ln of u times 1 over u minus 1 du. Is everybody following this so far? Okay. So then I did integration by parts. I said f is equal to ln of u. F prime would be 1 over u. G prime would be 1 over u minus 1. G would be the ln of u minus 1. So that gives me the ln of 2 times the ln of u times the ln of u minus 1 minus the integral of the ln of u minus 1 times 1 over u du. The derivative of this is this, yes?
Isn't it supposed to be 1 over ln 2?
Right here? Yep. Thank you. Okay. This, the 1 over u is the derivative of this, correct? Right? So I can figure out the antiderivative of this. This is going to be minus 1/2 the ln of u minus 1 squared plus c.
And so I have 1 over the ln of 2 times the ln of u times the ln of u minus 1. And then I replaced u of 1 plus 2 to the t times the ln of 2 to the t minus 1/2 the ln of 2 to the t squared plus c. And then I can plug in my point, and my point was what? 1 comma 2, correct? Right? So I can have 2 equals 1 over the ln of 2 plus the ln of 3 times the ln of 2 minus 1/2 the ln of 2 squared plus c. And then I can solve it. That's the way I did it. But you could use your calculator here and be a lot quicker. Alrighty. Who do we have left? Hannah, Ryan, Hannah, Ryan. Kind of cool when you think about it. I wonder what the odds of that happening were.
What number did Gavin do?
Gavin did 8B. Number 7, have I picked a number 7? Are you number 7? What's the next number? Number 6? You're up. You didn't know how to do number 6?
Well, I got part of it and then I did.
Oh, we can help you with the rest of that. That's okay. Why don't you come on up? Get comfortable.
I really don't know. That was like the one question I was hoping you did.
That was the one question I was hoping someone other than me got, because I also didn't get it, so.
How was this for?
Okay, so
Okay.
you have what, how did you start?
Okay, so two particles start at the origin and move along the x-axis for 0 through or t 0 through 10. Their respective position functions are given by x sub 1 equals sine t and x sub 2 equals e to the negative 2t minus 1. For how many values of t do the particles have the same velocity?
Okay, so.
So I took the derivative of both of
Yep,
them.
I would too. Can you slide it up and to the right a little bit? There you go. Okay, so you took.
So these guys.
Okay, now you will not be able to. I think the -1 is gone.
Probably, yeah.
And I think you got to use a calculator.
Yeah.
And you want your calculator?
I love it. I would love
I
my
would
calculator.
say you have to have.
I was trying to do it without one.
Yeah,
like
that-
trying as much as I could without one.
Yeah, I do not know. I have no idea how you would do that one without one.
Oh, of course. Okay.
Because one's exponential and one's trig, so it's not like there's.
So would I just try to find the intersections on
You
this?
got it.
Really? It's that slow? Oh.
That's okay.
So what? Can you see this? Got a graph there.
Yeah, you may. Oh, that's kind of a cool graph.
Yeah.
Can you change the window a little bit?
Sure. Oop. I'll try to make it a bit bigger. Wait, I don't know why I'm doing that. Stop.
And you want your intervals from 0 to 10, correct?
Yeah, so we
make
don't
your
need-
X max 10.
Yeah, 10. Should go a little bit over that, maybe.
Yeah, you can.
That's what I do at least.
Yeah, that's probably a good thing. So there's 1, there's 2. Oh, that's just hitting the x-axis. This is
Yeah. 1, 2,
2.
2.
So where does that look like? It looks like it's is 1 cosine?
Yeah.
Yeah.
I think you still have the -1 in your calculator on your.
Oh, you're right. I Apparently, I just
Oh,
cannot
yeah.
do anything.
That's what I'm saying.
So that's probably why I looked so weird.
I'm not even observant to that.
Yeah. There we go. That looks a bit different.
Yeah.
So we have
So it's
one,
3, I think.
2, 3, 4.
I went a bit over on the X, so.
Oh, so you're past 10?
So yeah, I think so at least. So 10 should be here.
Yeah,
Okay.
that makes sense.
So you have 1,
So
2,
there's 3 of
3.
them.
Okay. And are some of them when y is 0?
No. Because it never
Huh?
hits.
Very close, but never actually.
Oh yeah, because they can't be 0, because e can't be 0. Okay.
And that's
Alright,
all the
that's
question.
it?
That's all the question seems to be asking is how many values of t do the particles have the same velocity?
Yeah,
So it's
That's
3.
it. So it's just 3.
3, just
That's
3.
just the
Do you
answer.
have to label it?
It doesn't ask you to.
Oh, well, that's nice.
The one thing I would say is you made them equal to each other.
Mm-hmm.
And if this was an AP exam, I would find the intersections and label it, because I'd be paranoid,
Mm-hmm.
and say 3 here. But I would show that they're equal, and there is no algebraic way to solve that.
All right.
So if we try to get it reduced yet?
What?
If we try to get it reduced yet?
No. Because when you try to do an impossible task, you even reach into the realm of doing and that,
You, like, surpass
and,
it.
and hopefully before you do that, you say, you know what, I'm gonna throw this on the calculator.
We'll just
Alrighty.
surpass it.
Not bad. Okay? Alrighty.
What's this?
These have to be complete, so hopefully if you didn't get them, you're putting them down. You did not need to put mine down. Does everybody understand that?
We did it?
No, for mine, if you had, remember how I said you had to figure out the area under the curve, but you could have done that by your calculator?
Yeah, we just had that part.
Yeah.
Okay.
Okay, because that would have been reasonable to do. I just thought it was interesting that it could be solved. 7, we've done, have we done 6?
Yeah. I think 6 was John. No, we're saying you're number 6.
Line function of hypotenuse.
But this also has direction.
All right, number 1's gone, number 8.
It's me. I haven't done this one.
Okay, which one's this? 7?
That's what I do.
They haven't done yet, so. Here's my paper.
Okay, so just read 7.
Yeah, sneak over.
And did we say that Ellie had 8A?
I think that's what we thought. Okay.
A particle travels along a straight line. Go ahead and you read it.
A particle travels along a straight line with a velocity of v of t equals 3e over 1 half sine 2t meters per second. What is the total distance traveled by the particle during the time interval 0 is less than equal to t is less than equal to 2 seconds? So for that, you would want to find the antiderivative to get the position function?
Well, you're not going to do it by hand again.
Yeah.
Okay, well, I suppose you could if you wanted to do integration by parts, okay? But I am assuming that this one is a calculator problem,
I think so.
okay? So what do you have to integrate to figure out total distance?
You have to integrate from 0 to 2.
What do you integrate from 0 to 2?
V of t.
You have to be careful, Because since you have sine, you may go underneath the x-axis, correct?
Yes.
And that would give you displacement
Oh.
rather than total distance.
So you'd want the absolute value of v of t.
Yep.
That was kind of small and messy.
And do you have your calculator with you?
I do not. It's very slow though, so if we enter in a function, it might take hours to finish graphing. So we could still use it. I don't know. It's been
Let's
doing
give it a
better.
go. Let's give it a go.
Let's give it a go.
I don't even get to wait. Oh, I'm gonna change the mode. Because you're on parameters, okay?
On parameters? Oh, didn't know that. That's probably why I was showing up as t then.
Okay,
And then it'd be from 0 to 2t. 0 to 2.
0 to 2, yep.
Okay, so v of t
And this
is.
would be a good review on how to do this on your calculator.
So v of t would be.
You could actually, if you want, if you went to math, well, why don't you clear that? I'm gonna give you a little heads up here. Why don't
Yeah.
you go to math and you go to number up on top and choose the absolute value right away. There you go. And then you just have to put y1. Or you could graph it on your, graph it on the calculator.
I think that's right.
Is it 0.5x or just 0.5?
Just negative 1/2. So negative 0.5.
Oh, E doesn't even have an x in it?
Nope. Does it? Am I not paying attention?
Oh, it doesn't. Wow. Yeah, maybe we could have done that, like, okay. I read it wrong, but go ahead.
We're already in it. The graph screwed up.
Okay, so what we need to do is adjust our window.
Yeah, we gotta wait for it to finish.
Okay, so let's go to your window. Let's go to your window. And we're integrating from what, 0 to what?
0 to 2.
So go from 0 for min and 2 for max.
And then probably, since it's sine.
Well, since it's absolute, I was gonna have you change it again.
Okay. Okay.
Let's make a y minimum 0 since we're in the first quadrant.
I messed up. 0 and then.
You can make that
10.
10, yeah. Okay, so let's graph it now. Can you raise it up a little bit higher, your calculator? There we go. There, and now
There.
figure out the area underneath that.
Is the area underneath this specifically,
Yeah,
or
from
just
0 to 2.
0 to 2?
So you know how to do that?
Yep.
Okay.
I can just do it all on my calculator.
Yeah.
Okay. So,
No, just on your graph.
oh, on my graph? What?
Yeah.
Oh, yeah. I don't. Okay.
Yeah, from there, just second calc. There you go. Why don't you type in 2?
This is the lower limit. And then upper limit's 2.
Is it shading? Or is it still thinking?
It's still thinking. There's this little bar up here.
Oh. There we go.
It's a very old calculator. It's from the 70s.
And what is the answer? 2.1?
2.135.
Very good.
Yay. Oop.
All right, who's left? Ryan and Hannah. So Ellie's supposed to do A. I don't think I got video from her. I'll look.
We'll just FaceTime. Just FaceTime.
FaceTime all.
I don't even need to